Hi, in this video I will tell you about UpSet plot. This is the minimal version of it taken from the Wikipedia. Why this name, I don't know. I know that it has nothing to do with the upset or upsetting somebody something. It's up and set merged together. And you can try to find the answer in the original paper. This one published in 2014, where authors suggested upset plot as a replacement of a Venn diagram in case of high complexity. They mentioned word set 663 times with or without up, but still I could not find out why they named this plot like this. So what's the point? They say that Venns do well at the small numbers of compared sets. Here you can see examples of a Venn for 3 and 5 sets. On the left, on the right 11. In the middle we have a Edwards diagram for 6 sets. But generally speaking, everything above 5 is difficult in Venn, and the intersection regions are getting small to super small, which creates a readability problem. It's hard to read numbers in those intersections. So the essential differences between Venn, Euler, and UpSet can be that in Venn and Euler every list is equal to another, no priorities. In UpSet you can set one list as the reference one to which you will apply all other combinations. In Venn Euler you show inevitably all the combinations, but in UpSet you show only selected ones. You can decide which combinations, how many you want to show, and so on. And I also have aesthetic concerns regarding upset plot, but you can ignore it. What is exactly this upset plot? You can scroll through the pages and see the original design. This upset plot is very different from what you see in the Wikipedia. It's a bit nicer, better looking, but very complicated. And it's not really a single plot, it's more like a page full of different types of the charts and plots. Of course, the essential part is this nodes diagram, so what combination it is, and the bar chart next to it shows frequency of this combination. This is actually a screenshot of the web page. The original UpSet page, web page, still exists, and you can visit it, and there are some data sets you can select. When the number of sets is small, then this chart is really confusing. The same set illustrated with a Venn diagram is simple and clear, and try to read it based on these combinations. I would prefer to have a Venn diagram. But if you move to the series of, for instance, mutations in a glioblastoma, 100 sets, then you realize that, okay, in this case, upset is certainly an advantage, because no way you can make 100 sets as a Venn diagram, simply not possible. But when you use an upset and also sort it by degrees of combinations, the single one, non-overlapping, then 2 occurrences in the data, then 3, then 4, and you exclude those which are not present at all, so all zeros are kicked out, then you realize, okay, in this case UpSet is pretty good illustration, and it works, it is helpful. Let's move on and try to make our own UpSet plot with the real data using, for instance, this package UpSetR. There are some others. It's useful to check these vignettes, at least first two, they are pretty useful. That's the basic usage, very basic plotting. Here we learned that you can create UpSet from list of any lists, like you do Venn diagrams, very good. In attribute plots, you learn that you can add some more attributes and colors. Not every instruction is useful. Graph Gallery surprised me with this script, which is not very helpful. Speaking of that, I decided to run in comparison Euler plots and UpSet using string to convert my lists. Using data pizza recipes from local pizzerias, from 2 of them, all vegetarian. So first I take all these recipes, name, price, composition, then I create a matrix out of it, which is again now in columns, name, price, and composition. Rename the column names, save the table, open table, add the short description, what is what over here, which is unique. And then I want list of all of ingredients used in all pizzas, do these lines, and check what is used as is. Nice. Now I do assignments to a short names the recipes which are in a table. That's what I do in a loop. And if I call pepperoni recipe, that will say these 5 ingredients. And now I create list of lists, so a full name, short name with the recipe, that's my X. I do not use colors, instead I will use rainbow colors. And now I ask Euler to give me first 10 recipes in a shape of ellipse. And why Euler, not Venn? Because the Venn will fail. Euler is more flexible. Okay, it took me about a minute to do a fit, and now we can plot it. That's the plot. If it was, let's say, 5 or 3, then it would be a nice picture. For instance, this one is okay. But with 10, it is ugly. As we learned from vignettes, we can use the same list of lists directly in an UpSet plot, and I say, okay, give me a list of 11. This function also creates a matrix of zeros and ones, where in columns you have pizzas and in rows recipes. Only the problem is, in this automatic conversion, you miss the ingredients names, unfortunately. And it looks like they are not anywhere. And of course you have a plot. No colors here, no extra figures, but this one by itself is just as usual. Even though UpSet can import data from list, the native way of reading data is this matrix of zeros and ones, which we better create ourselves. First you have to check the sizes of your lists. So I have in total 24 ingredients and 14 recipes of different pizzas. You can call anything out of your lists by command get. For instance, number 1 is margarita, tomato sauce and course, and cheese. That's a Dutch one. And first you create a data frame of this size with the columns of pizzas and row names of ingredients. At the beginning they're all zeros. Now we add row names and column names. Again, check it. And the whole magic happens in this loop. Then it will go through the data frame and check all these ingredients for every pizza type. And if, for instance, tomato sauce was used for margarita, then it will set 1 over here, and pepperoni and vegetarian and so on. So that's all happens in this loop, which is small and powerful. And now check it again. We have this table of zeros and ones. That's the most authentic source of the UpSet. And of course you can add more columns, all numeric. If you want to do some extra illustrations in UpSet, but for the basic plot it's not necessary. For instance, I can add a row sums for ingredients, but I don't have to use it. And this column will be ignored by the UpSet function. There are lots of parameters in an UpSet function. Importantly, you can limit number of sets by this line and number of intersects you want to show by this line, and there are a lot more options. So again, UpSet data frame, zeros and ones, number of sets, order by frequency, it works. And if you want to see frequencies of ingredients, you can do a bar plot. Of course, you can try these attribute plots, although the way you call it is a bit awkward. So within UpSet, you have to call some attribute plots, which is a list where you define parameters. Within a plots, again, you call a list, and list again, which one is histogram, so not everything is allowed, what's the column to read, and so on, so on. At the end, it looks pretty nice, although it's a bit too complicated. Why cannot I make this plot on its own? Why should I do it within UpSet? That's my biggest why question to the designers. And if you want to compare pizzas and ask, for instance, how different are they between, you can use a vegan library and generate MDS plot, which is this one, and see, for instance, that this He and P2 are very close and some are very far. And if you want to know what is this He and P2, go to menu, this one Cipolla and Fungi and Peperonata, then indeed you see that they differ only by adding either paprika in one pizza or oregano in another. That's why they're so close. And this plot is not included in the attribute plots of the UpSet, but you are free to choose and use whatever you like. I hope it was clear enough regarding theory and practical parts, and Keep in mind that there are no universally good illustrations. The illustration you choose should match to the data you have, not other way around. And have a good time.